Hi, and welcome to this short video presentation that I've put together to demonstrate the importance of 3D modelling and engineering drawings for Silver Cross. My name is Brian Edwards and I'm a time-served toolmaker. I'm a graduate mechanical engineer and also a chartered engineer. And last year I spent some time pulling together a tooling register for Silver Cross. And it was during that process that I discovered that a lot of the drawings were either missing or inaccurate. And it's that I want to talk to you about today. So if you just join me over here and I'll go through it with you. Let's take a look at this component, which is the hood joint. What we can see quite clearly from this drawing, that we can't make it from this drawing because there are some dimensions missing. The crucial one is this dimension here, which is the overall length of the product. It's just not showing on this drawing, so we don't know how long to make the product to start with. Whilst there's information regarding the flat that's stamped on at this end in terms of width, there's no dimension showing us what the length of that flat is from there to there. There's no radius information when we start bending this product as to what radius is required there. And whilst there's a little information, or quite detailed information, about the thread on the male part of the hood joint, there's absolutely no information about this component here, and neither is there a separate drawing for it. So this component, which is crucial for the overall subassembly, is not dimensioned at all. And this key information here obviously would be what is that dimension there between the centre of that hole and the end of the component. So really you just can't make this product, and what we're looking at here is what is the effect of not having up-to-date drawings or accurate drawings. And there are three main things to look at. One, how do we manufacture it if we haven't got a drawing? Two, what about the quality system? And three, what if we change a supplier? Now, just quickly taking those in order, how would we manufacture this product? Well, clearly the only way to manufacture it is from the drawing that we've got, which is quite frankly next to useless, or we have to measure an existing component. Obviously, if we measure an existing component, we're measuring that component in that period of time, and you may actually make a drawing from it, of course, at that time, but what about the ones that have gone in the past? And continuing on this path, what you get is every time you measure a component without a drawing to make a new one, then you introduce an error, and that error can get compounded every time that happens. So you can imagine what would happen to a spares business 10 years down the line when you're making a component that all of a sudden now doesn't fit a pram that was made 10 years ago. Now secondly, assuming there's a quality system in place, what about the quality system? Surely it requires a drawing for every component that's manufactured. How else can you guarantee the fundamental statement in a quality system that says we're going to make this component to conform every time we make it? How do you know it conforms if you haven't got a drawing? And lastly, what if we change a supplier? Either the main supplier for all the components or a subcontract supplier to that main supplier. How are they going to make that first product? Whose fault is it if it doesn't fit? So you can see the importance of this. So now let's look at the model part. Here you can see the hood joint that I've modelled. I've had to assume some dimensions and scale the drawing, which of course is a no-no. But should this project go ahead, then we'll take some accurate dimensions from existing parts. Once we have this model, we can examine it in more detail. We can rotate it around, have a look, make sure it's as it was intended. We can then take a look at a more detailed view. We can zoom in, look at this flat for instance, see how that works. We can zoom right in here and look at this component that until now didn't exist, and we can even move this component away from the male rod itself to see how it works. Now, having modelled a few parts, we can then start putting them together in sub-assemblies like we have here. We've now added the short arm joints to this and the pivot point. We can do it as before. We can take a detailed look at important aspects of this sub-assembly. For instance, what's it look like here? Is there anything interfering? Zoom back out again, rotate as before. Also, we can look at some motion to make sure that it's moving as expected. A further thing we can do with this sub-assembly is to give someone a better idea of how it fits together. I know this is a simple part, but I think you'll get the idea that we can pull these components apart like this and give a reasonable bill of materials to show you how the whole sub-assembly is constructed. Now, once we have the model complete, it's quite a straightforward process to drop out the drawings from this and add the necessary dimensions. So now we have a fully dimensioned drawing of the 14-inch hood joint. Oh, and you remember the pivot block that never existed as a drawing? Well, as you can see, it does now. Well, I hope you found that interesting, and if you do want my help in getting these engineering drawings up to date, or indeed if you've got any modelling and engineering drawing work on product developments, for instance, then please don't hesitate to get in touch. You'll find my details on the following slide. Thanks for looking.